Once again, a very good evening to all of you. Let us begin with the assignment solving session, or rather a clarity class, where we might see some new concepts, but at the same time, we'll focus mainly on uh, understanding the numericals which were sent to you all by chat. Yes. So the first one, so this was the assignment was this was the assignment which was meant for the chapter kinematics, and mostly we had the topics covered were application of differentiation and integration, right? So let us start off. Once I finish a question, as I said, I'll be giving a time. You may ask your queries in that given time. So the first question, you were told that the velocity of a particle v is given as pt plus qtq. Then you were told find out the displacement between find out the displacement between, that is, let's say s, between t is equal to 0 to t is equal to 5 seconds, right? हमको इस टाइम के बीच का डिस्प्लेसमेंट फाइंड करना है, right? How do you actually do that? In order to find out this displacement between t is equal to 0 to t is equal to 5, you will write, try recalling or take this as a lesson, that whenever I have been given with displacement and I have to find velocity, all I'm going to do is differentiate. So I'll write it better. Have a look. जैसे we had, whenever we have to go from displacement to velocity, we have to differentiate. Please write this down. This is a short trick which is going to help you all when you're solving such questions. Going from displacement to velocity, you'll have to differentiate. From velocity to acceleration, you have to again differentiate. From acceleration to velocity, you'll have to integrate. Right? Similarly, again, if we have to go from velocity to displacement, you have to integrate. Right? So see the question. What does the question give you? Question gives you velocity. What are you asked to find out? Displacement. See, you have to find out it is velocity is given, right? Velocity is given and you have to find out displacement. That means you need to integrate. Simply do the same. Here you will write, instead of v, you will write dx by dt is equal to pt plus qtq, correct? Try recalling the steps. First step in such cases was group the similar variables together, right? So you will take dx is equal to pt plus qt cube into dt. See, dt comes with t cube. Then second step was integrate. So you integrate on both sides, right? Then third step was take the limits, right? In some cases, limits might be given, some cases limits might not be given, right? So here, this x is nothing but position, right? So we may take, suppose initially position is whatever, let's say 0, at t is equal to 0. At t is equal to t, position is suppose x. Now you have integration of 1 on the LHS, it becomes x. Simple, 0 to x. Here 1 by 1 integrate pt, you will have pt square by 2, right? Here you will have q t power 4 upon 4, right? Now take the limits from 0 to t, all you are going to get the value of you're going to get value of displacement at any given time t, right? Then find out the displacement. So here you'll get displacement as a function of t, right? Or position as a function of t. So now position at any given time is given. So you might take position at t is equal to 5 minus position at t is equal to 0. This will give you displacement. This is one way of doing the question. Another way is you change your limits. So you might wish to write integration from 0, instead of writing 0 to x, write it, or just write 0 to x dx, given as, instead of writing 0 to t, right here directly from 0 to 5, right? And then you integrate. So what will be the difference? Integration result will be the same, just limit substitution will be different. See, pt plus qt cube dt will give you pt square by 2 plus q into t power 4 by 4. Take the limits from 0 to 5, substitute the limits p by 2 into 5 square plus q by 4 into 5 power 4 minus p by 2 into 0 minus plus q by 4 into 0 power 4, right? So this will give you p by 2 into 5 square plus q by 4 into 5 power 4. So this will be your answer, and here you will have x minus 0, and therefore this is x, and you will call it as displacement. Right. So is the concept clear to everyone? This question was basically based on one of the, I think, past year NEET or JEE questions. In fact, all of these questions are based on past year questions. So if this question is unclear to anyone, please raise your hand and ask. Yes. Yes, class. Anyone who wants to ask? Anybody? All right. So if you all are clear, let's move to next question. So we will have next question. You were given that you were given that a particle is going according to the term or displacement term given as a function in time 1 by t power 5. This is a very good question. Why? Because many candidates would not be able to crack it in first go. So see, what are we going to do? What is asked? You're being asked, what is acceleration proportional to? What is acceleration proportional to, right? So for such a question, your approach has to be all very similar to what we just read. See here, you have been given with displacement, and you have to find out acceleration, right? So all you're going to do, differentiate it twice. Clear, right? We will go from displacement into velocity, right? Then after differentiating velocity, you will get acceleration. So you have different options. We'll see that later. We'll take this here. We'll write dx by dt, right? This will be given as, this is t power 5 d by dt of t power 5 to the power minus 1. Use chain rule. We know that this term comes in front. So right here minus 1 into t plus 5 to the power of minus 1 into d by dt of t plus 5. This will give you minus of t plus 5 to the power of minus 2. Recall chain rule, right? So you will have velocity v. This was what? This was velocity. So velocity v is nothing but 1 by t plus 5 to the power of 2, right? So this is giving you the value of velocity, right? Now you have got the velocity. Now you are supposed to find out what is the acceleration. Recall, acceleration had two formulas. One was dv by dt, the other was v dv by dx. This morning we had learned that when do you use which formula? We use the formula dv by dt when velocity is given in terms of time, which is evident here. Here, velocity is given as a function in time. So, all I'm going to do is differentiate this term which is given and then go ahead with understanding the concept, right? So, do the same. You have been given v, so differentiate it dv by dt, right? Will give you, have a look again. So this will be d by dt of minus 1 by t plus 5 whole square, which gives you, take minus sign common, this becomes, or outside, this becomes d by dt of t plus 5 to the power minus 2. What will happen again? Minus 2 will come here and you will have, let minus 1 remain, minus 2 into t plus 5 to the power of minus 3 into differentiation of t plus 5, which is nothing but 1. So you have 2 upon t plus 5 raised to the power 3 is the value of acceleration. Okay, that is all right. But in the question, what does it give? See, the question talks about 4 different options. It says acceleration varies as, or acceleration is proportional to which of the following? V power 3 by 2, x square, or x power minus 2, or v power 2 by 3. How do you calculate such expressions? Very simple. See, try to see what is the link which is connecting the three. So in order to make that clear, we will write each of them separately here. So first, see what was x. The value of x given was 1 by t power 1 by t plus 5. Right here, x was 1 by t plus 5. What is the value of velocity given? Value of velocity is given as minus 1 by t plus 5 whole square. So you'll have minus 1 by t plus 5 whole square. Then you have acceleration a. We got this as 2 by t plus 5 whole cube. You have 2 by t plus 5 whole cube, right? So what is acceleration proportional to? Proportional as in constant doesn't matter, right? What is it proportional to? So let us find it, this acceleration in terms of, let us find acceleration in terms of x and v, and let's try to see if it fits one of the options given, right? So we have x is given as 1 by t power 5. So we can write here 2 into 1 by t plus 5 to the power of 3, right? Which is nothing but 2 into x cube. See, right? 2 into x cube. Another way of expressing velocity in terms of, or sorry, acceleration in terms of velocity, right? So from here we can have 1 by t plus 5 is nothing but, you can write 1 by t plus 5 square is nothing but, or let's say, let us write this in terms of proportionality, right? So from here we can see that 1 by t plus 5 square is proportional to v. It means that 1 plus t power 5, 1 plus t, 1 by t plus 5 is proportional to under root of v. See, we took root on both sides, correct? So if acceleration is proportional to 1 upon t plus 5 whole cube, right? And we know that 1 upon t plus 5 is proportional to v power 1 by 2. See, the root of v is 1 by 2, correct? So we can write, therefore, a is proportional to v power 1 by 2 whole to the power 3. This implies acceleration is proportional to, from here, x cube, and acceleration is proportional to v power 3 by 2. Now try to see which option does it match. So I can clearly see it matches option number 1. See the 4 choices given, it matches option number 1. So A is your answer. I will quickly repeat what did we do. All we did was simply differentiate the expression twice. We got velocity and acceleration. Then all we did was, once you have displacement, velocity and acceleration, try expressing acceleration in terms of displacement and velocity, right? All we did was just see 1 by t, 1 upon t plus 5, how much is it equal to, right? Or what is it proportional to? So 1 upon t plus 5 is proportional to x. In the similar manner, 1 upon t plus 5 whole square is proportional to v. Therefore, 1 upon t plus 5 is proportional to v power 1 by 2 or root of v. All you did was just that, substitute it here, and you get the right expressions, right? All right, class. So any queries in question number 2, in understanding of question number 2, please raise your hand. Anyone? All right. Let's then transit to question number 3. So question number 3 is very motivating and at the same time connecting question. Why? See, you have been given. So let's take any one of you, anyone who would like to give a try. How do you solve this question? Yes, please raise your hand. Anyone who would like to just give a try that in your approach in the question number 3. Yes, please raise your hand. Anyone? Anyone? Okay. Yes, Siddharth, go ahead. So I think I'll open the mic just a minute. Yeah.
So
Yes, Siddharth, tell me. So we have been given. Let me just let me just once tell the question. Repeat the question. We have been given with a graph wherein it is a graph between acceleration and time, right? Acceleration and time. Here we have been given acceleration is 10,
yes,
and at this point time is 20. Let us say this is seconds, the SI units, and here this is meter per second square. Now we are being told that find the relation between velocity and time. All right, velocity and time. But before that, I think we have to find out relation between speed and time, right? So, or before that, we need to find out relation between acceleration and time. Yeah. Siddharth, can we find relation between acceleration and time using the equation?
Yes, sir. We can use the intercept form x by
yes.
a plus y by b.
Yes, yes. Tell me, what will it be? A by 10 plus t by
plus t by 20
is equal to
equals 1.
1, right? So this gives you
yes,
a by 10 can be written as 1 minus t by 20, correct? So 20, you can have a as 10 times of 1 minus t by 20. Am I correct, Siddharth?
Yes, sir.
Right. So once you get this, you have a relation between acceleration and time. Now, given acceleration relation in terms of time, all you're going to do is apply the technique we have learned this morning. What if we have to go from acceleration to velocity? What are you going to do? Integrate it. Integrate it. Right. Absolutely correct. Absolutely correct. So here you're going to express, you have two ways of expressing acceleration. One way is writing dv by dt, and the other is v dv by dx. Which one do you think should be adapted, Siddharth?
Sir, we can use dv by dt because we have it directly in terms of time.
Right. So we'll write, since acceleration is given in terms of time, we will take a is equal to dv by dt, is equal to 10 minus t by 2, and all we have to do, right, group the variables. I'll repeat for everyone. The steps are: group the variables together. So take dt on the RHS.
Yes, sir.
Next step is integrate both sides.
Yes, sir.
Correct. Next step is take the limits. See, are the limits given in the question, Siddharth?
No, sir.
They are. See, the limits are given very subtly. limits are given in the way they are saying if initially the particle is at rest. See, if
Yes, sir.
initially is at time t is equal to 0, and when you're saying
0.
particle is at rest, I mean velocity is how much? 0.
0.
Right. So you have at t is equal to 0, you have
V
velocity is
equals 0.
0. And let's
Yes,
say
sir.
at t is equal to t, velocity is v. So this is how the limits were given, but they will not always explicitly tell you that at t is equal to 0, v is equal to 0. Right, Siddharth?
Yes, sir.
Now,
Yes, sir.
what are we going to do? We are going to integrate this expression.
Integrate.
Easy.
Yes, sir.
Integration of 1 with respect to v will give you v, right?
V.
Substitute the limits. How will you do it? So
So
let us,
first we substitute V
yeah, so we'll have, let's take it from 0 to v. We'll write v minus 0, correct?
minus 0.
Right.
Yes, sir.
Now, for the RHS, we'll have it as, tell me, 10t minus
t
t
squared
square
by
by
4
4, right? 2 into 2.
between
Absolutely
0
correct.
and t.
Right. And now the limits are 0 to t. So obviously
Yes,
both
sir.
terms have t in them. So even if you substitute 0, you'll get the same answer. So we will have v is equal to 10t minus t
Yes, sir.
square by 4. 10t
10t
minus
t squared
t
by 4.
square by
Yes,
4.
sir.
Right.
T
Since you're
squared
taking the
by
limits from 0 to
4.
t, this will cause no change because we will have
So t
0.
squared.
Okay. All right. It's t square. Right. So we'll have t square by 4 minus
4
of 0 minus 0, correct?
0 minus
So we
0.
got
Yes, sir.
velocity as 10t minus t square by 4, correct?
By 4. Yes,
After
sir.
this, now we have got the
After
first answer. See, what does the first question say? It says that find the relation between v and t,
between V and T.
right? So we have
Yes, sir.
covered the first step. Now, what is the next thing being asked? Find the velocity at
Find the velocity
at t is equal to 10 at t is equal to 20, right? So
20.
let's try
Yes, sir.
doing it. Can you do it from this equation?
So
Right?
we can just substitute it directly, right?
Substitute. Absolutely correct. So you're supposed to find out what is the velocity at time t is equal to 10. So class, I would like
10.
to emphasize for everybody's attention, see what we have done. In the question, we were given a graph between acceleration and time. From there, we obtained the relation between acceleration and time. And we all just read this morning that whenever acceleration is given, in order to find velocity relation, you have to integrate it from velocity to go to displacement. You also have to again integrate it. For the vice versa process, you have to differentiate it, right? Now,
Yes, sir.
we did the same here. We got the expression for acceleration. We integrated it by substituting, instead of a, we wrote dv by dt, took similar terms on same side, integrated, applied the limits, and got the answer
dv by
as v is equal to 10t minus t square by 4. Many students would have seen this for the first time. It might take some time to absorb, right? So we'll wait for a minute after the completion of questions so that you can take time and absorb what we just understood, right? So let's continue. So in order to find out from the given expression
Yes, sir.
what is velocity at t is equal to 10, all you're going to do is substitute 10 instead of t, correct? So you'll have this as the
Yes, sir.
value, right?
So
And
minus 100 by 4.
right, so it's giving a 100 minus 25, that is 75 meter,
75 units per second.
right? Now the next point, at t is equal to 20,
Yes, sir.
what is the velocity? It is equal to 10 into 20 minus 20 square by 4, correct? This gives me 200 minus 400 upon 4,
Yes, sir.
that is 100 meter
100.
per second. Can you verify that?
Yes, sir. That's what I got.
Right? So we have
Yeah.
got the expression for velocity. using this expression, we found the velocity at any two given instants of time. So class, just for the information
Yes,
of
sir.
everyone, this velocity, which is given in function of time, is specifically called as instantaneous velocity. I hope everyone is aware with the concept. This is called as instantaneous velocity, right? Instantaneous velocity. So,
Sir, what happens if we don't apply the limits in a question like this? I'm so sorry to interrupt.
sorry, yeah, go ahead. What?
What happens if we don't apply the limits in a question like this? Because that's how I did it. It didn't strike me to apply the limits, but I still got the answers for a velocity at the given time
Yeah,
and all
because
that.
observe that in this question, coincidentally, for zero time, we have zero velocity. So because of this
Yes, sir.
coincidence, you got the right answer. But in case you do not get, of course, if you don't apply the right limits, you will end up getting the wrong answer if the limits change. So
Yes, sir.
supposingly, initially velocity was not zero. Supposingly, it was
Yes,
some
sir.
constant quantity, like let's say two. You know. So let's say if
Yes,
the
sir.
velocity was two initially, so instead of zero, you will have two here, right? So you
Yes,
will
sir.
write v minus 2 is equal to this entire expression, correct? This 2 will
Yes, sir.
migrate on the other side and you will have a plus 2 term here. So your answer will differ by 2 in that case.
Yes, sir.
Trying to understand, Siddharth, should I repeat?
Yeah. No, sir, it's fine.
Right?
I think
So,
I understood.
yeah. So basically, the point is always make sure that when you have a question of this sort, follow the strategy which we had discussed this morning. Always
Yes, sir.
first make sure you group similar variables, integrate, and the third step is apply limits, and then find whatever you want to, right?
Yes, sir.
All right. So, class, let us see the next part of this question. Siddharth, see, yeah. So we have been asked find the time when body again comes to rest. So, see, why is it saying again? Because we have been given in the question that the body is starting with rest. We are being asked, does the body again come to rest? See, so I have also asked in a bracket that does this happen? That means, does the body actually come to rest again? To find that out, what are we going to do? Instead of, right, so we have velocity v is equal to 10t minus t square by 4. What does coming to rest imply, Siddharth, in terms of velocity? Okay, I think, Siddharth, I'll unmute everyone once again. Just give me a second.
Sure.
Yeah, right. Yes, Siddharth, your mic is on, right? Yeah, go ahead. So,
So
what are
the
yeah.
yeah. So
So
the
whenever,
velocity goes to zero again at rest.
yes, absolutely correct. So whenever we have been told that velocity, we are being asked what is the time when when the object is at rest. So it means that velocity of the object is zero. So what is that time when the
Yes, sir.
velocity is zero? So in order to find out that, in this expression of v is equal to 10t minus
We equate to zero.
t square by 4, we will write v as 0. So this is
Yes, sir.
how we all will end up in the final expression, which is 10t minus 10t is equal to t square by 4,
T squared by
right?
four.
Now there are two ways of understanding this. So you can either take 10 common, so you will have, or t common, so you will have 10 minus t by 4, right? What will this expression
Yes, sir.
give you? This expression will give you either t is equal to 0 or 10
Or t
minus
equals
t by
40.
4 is equal to 0, right? That
Yeah.
is t is equal to 40. That
40.
means
Okay.
at at t is equal to 0 and at t is equal to 40, velocity is becoming 0. Of
Zero.
course, in the question it is rightly said. See, the question is rightly saying that the object is starting with a zero velocity, right? So we are
Yes, sir.
attaining this expression again by the value of time which we have got when we have equated v to 0. So basically
Yes,
what
sir.
we have done, in essence, we have calculated a relation between velocity and time by the use of
Yes, sir.
integration method we discussed in the class today. Once we have got this expression, all we have done is substitute v as 0, because you are being asked when will the velocity become 0 again, or when will the object come to rest again. So we
Yes, sir.
see that we get two values of time. One is t is equal to 0 and the other is t is equal to 40. It means that
40 seconds.
at both of these times the object is at rest. So this conceptual
Okay.
understanding is very important, that at both of these times velocity is 0. This is coincidentally initial time or initial point of motion, and this is somewhere at some random point t is equal to 40. So our
40.
answer for the question will be at t is equal to 40 seconds, velocity of the body turns out to be 0, right? So this is
0
the
again.
answer,
Yes, sir.
correct? Are
Yes,
you
sir.
clear with this, Siddharth?
Yes, sir.
All right, thank you, Siddharth.
Thank
So
you, sir.
everybody in the class, kindly raise your hand in case this question is seems any like has any doubt at your end, so that we'll take it up. Okay, I think I had got two messages from Shivani and Mahila. Both of you were trying. All right, all right. I think Mahila, perhaps you might be very close to attaining the answer. Let's see. We got the answers at 75 and 100. All right, absolutely correct, Mahila. Your approach is absolutely correct. We got the right answer. You got the right answers. And I think Shivani, you had also properly found out. I think you have written A is equal to T by, I think you have given the answer. A is equal to, uh, yeah, somewhere close, just a little bit of minute error. No worries. You were very close, Shivani. Yes. So I hope, Shivani, the question is clear at your end. In case not, please let me know. Okay. So everybody, please have a look at the question one by one. I will pause at every screen. If you have not finished any point, please see the question once, right? Satisfy yourself with the working, and anywhere you have any query, I am there. Let me know. Yeah. You may raise your hand if you have any query to uh, tell. Yes, please look at the question, look at the solution, absorb it. Anywhere you want me to clarify things again, I'll do it for you. Tell me. Yeah. So this is question page 1. Then we move to page 2. And then page 3. Yes. Anyone, any queries, please raise your hand. I think there must be queries because this is a little intriguing kind of question, not very common. Class, such questions can appear in this year JEE exams or NEET exams, so please be prepared, right? So this is one of the most probable question. I will again give it 2 stars. Please make sure you do this question. All right, so let's go to the next point. You have class, are you sure everybody's clear? Please raise your hand in case not. You may also ask tomorrow, no worries. Take your time, absorb the question. Ask me if you have any query. Yes, anybody in the class with queries? All right, okay. So let's take next question. Next question was very straightforward and simple. You were given integration of x square plus x minus 1 dx. Now we have one simple formula given to you all in the formula sheet. It is x power n plus 1 upon n plus 1. Simple. Integrate it. You will get x cube by 3 plus x square by 2 minus x. Right? Anyone, any queries with this? Please raise your hand. Let me know. All right. All right. All right. Right. So yes, absolutely correct, Mahila. The answer is absolutely correct. Let us take now another question. We are being given that x is equal to t cube plus 2t minus 1. We have v is equal to, we have to find out, we have to find what is a, right? Now, simple. Try recalling. Whenever displacement is given, we have to go to velocity and acceleration. See what we have to do. We have to from displacement to go to velocity, we have to differentiate, and again from to go from velocity to acceleration, we have to differentiate. Please make sure you write this trick in your formula copy or the lecture copy that you are making along this around like during this lecture, right? So you have to differentiate, right? That is the lesson. So differentiate this expression, you will get v is equal to dx upon dt, which is equal to 3t square plus 2 minus 0, correct? Now what is acceleration? dv by dt. We might have taken, we should have taken v dv by dx, but here we have been given expression in terms of time, velocity is in terms of time, it is given as 3t square, and therefore you differentiate in terms of t, right? Therefore you choose this formula over the other, we choose dv by dt rather than v dv by dx. Differentiate it, you will get 60, correct? So these are the solutions for the question. Such questions are being asked in the past NEET year exam, NEET, since last 5 years, class. Since last 5 years, such questions have been asked in NEET exam. So please stay careful whenever you are appearing for or such questions appear in front of you. Again, they are probable when it comes to NEET examination, right? And occasionally such questions may be asked in JEE also. Okay, so coming to next part, we have A is equal to 2t minus 1. Okay, I think I have left this question blank, no worries. Uh, so the question says you have acceleration given as 2t minus 1. You are being told that the body starts from rest. It means v is equal to 0 at t is equal to 0, right? V is equal to 0 at t is equal to 0. Now body starts from rest. So this is the implication, class. Please make sure you understand this implication that whenever body is starting means t is equal to 0, and whenever it is saying rest means v or velocity is 0, right? No motion in the body now, or no net displacement in the body. Basically all you have to do is write this expression. If in order to find the velocity, what do you have to do? dv by dt is equal to 2t minus 1. Why? Because you had two expressions again, dv by dt and v dv by dx, right? It's just the same concept. If I explain again, it will be a redundancy, right? I hope everybody is clear. In case any doubt in question number 3, let me know. You have to find expression of velocity. You'll integrate it, right, in this manner. You'll get 2t square by 2 minus t, that is t square minus t, and here you will have take the limits from 0 to t and here from 0 to v. Why have we taken 0? Because at time t is equal to 0, velocity is 0. Have a look. Very important. Take this into consideration. At t is equal to 0, velocity v is 0. It's not necessary that always velocity will be 0. Sometimes you may be given some other velocity, right? Like the doubt which was asked by Siddharth just a short while back. So this is what the expression is. You have the expression given as v minus 0 is equal to t square minus t, or v is equal to t square minus t. Now I'll take 1 minute pause. Please absorb the question. See if you have any query, let me know. Yeah. Write this down in your copies. Any query, let me know. Yeah. Right. So class, anyone, any query, please let me know. Right. Anybody, any queries? Let me know. Right. So I think Krishna and Mahila had sent me answers. Yes, your answers were correct. Very good. Let us go to the next question then, in case there are no queries. All right. So class, also class, please be very free in asking any queries you have in mind. Okay. So we have next question. Just looking at it. Okay. So next question is saying, this is again a good question. You have been given that velocity is equal to alpha times of under root of x. Okay. Now you're being told displacement. How does it vary with time? Displacement, how does it vary with time? That means what will be the power of t in the formula for x? Class, listen to me clearly. What will be the power of t, right? So you're being asked n. If the power of t is n, you're being asked n, right? What is the power of t in the formula for x? How will you do it? Class, anybody? Yes. So let's say this time, any one of you. Monica, will you take the charge? Yes. I'll. Yes, the candidates are unmuted. Okay. Yes, Monica. Try.
Hello.
Yes. So what will you do? First step, b is equal to alpha root x is given. You have to find what is the relation between x and t. That means you have to go from velocity to x, that is displacement. So what do you have to do?
We'll have to integrate
Integrate.
the
Right.
given equation.
Right. What is the formula for velocity?
Dx by dt is equal to
Absolutely correct. Is equal to, so you have dx whole by root of x, and this is equal to alpha dt. Correct,
alpha
Monica?
dt.
Right.
Yeah.
Now let us integrate on both sides. Let us integrate on both sides. Correct? Right. So irrespective of the limit. So Siddharth, answering your query again, suppose you are being asked about proportionality. Again, whenever you are being asked about proportionality and not the exact answer, Siddharth, again here, your not taking the limits would still give you the right answer. Siddharth, am I clear? When you are being asked in the question about proportionality rather than the actual answer, you will still get the right answer. Right, Siddharth? All right. So in this question, since we are being told about proportionality plus, so this was Siddharth's question, that sir, if we are being asked about proportionality, or when, what will happen? What will happen if I do not take limits? So if you do not take limits, you will get the correct proportionality, but you will not get the exact correct answer, right? So in this question, we are talking about proportionality. So not taking the limits would suffice. For proportionality, not taking the limits would suffice, right? And of course, in this question, we don't have any limits also given. Generally, in the question, they will give you the limits if they have to be substituted. Yes, Monica, continue. So how will you solve it further? Yes.
We can take this as x power minus 1 by 2.
Absolutely correct, Monica. Absolutely correct. dx, right, is equal to alpha into t, right?
Yeah.
Now, integration of x power minus 1 by 2 should be minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. Am I correct, Monica?
Yeah. Yes,
Right.
sir.
So you have x power 1 by 2 is
1 by 2
proportional
upon 1
to
by 2.
t. Is proportional. Let's now convert into proportionality.
Okay.
Correct? Because
Yeah.
in the question we have been asked what is x proportional to, what power of t, right? So we have
Right.
x root proportional to t, therefore x is proportional
X
to
is proportional to t
t
square.
square, right? Squaring both sides. Are you clear with this concept, Monica?
Yes, sir.
All right. Thank you, Monica.
Thank you, sir.
So class, anybody else who has a query with this question, please shoot. Yes. Class, anybody with any query in this question, please shoot. Yes. Okay. So once we are done with this, let us begin with the next question. The next question is again interesting. It tells you, it's a question based on the three equations and motion under gravity which we revised this morning. So suppose you have a building, and from the top of the building you are dropping a ball. So let's say this is next question. You are dropping a ball from the top of the building, right? You're being told that the building's height is h naught. This height of the building is h naught. The ball is being released. Whenever you come across these terms, no class, dropped or released, right? These terms imply that the initial velocity of the ball is 0, right? Now you're being told that the total time this ball takes to reach is capital T. So if here time was t is equal to 0, by the time ball reached on the ground, the time was t is equal to capital T. This is given. You're being told that find the height of the ball from the ground at time t is equal to t by 2. So how far above the ground is the ball at time t is equal to capital T by 2, right? So let us take this as small h, right? Suppose we have to find this small h in the question. How far above the ground the ball is placed at t is equal to t by 2 if the total time taken is capital T. How will you solve this question? You will first write three equations, right? Initially, if you are not very much used to solving such questions frequently, write three equations. S is equal to ut plus half at square, v square is equal to u square plus 2as, and v is equal to u plus at. Now check, here in the question, we are being told, or some kind of relation is being developed between displacement or height and time. Displacement or height and time. See that which of the relation connects displacement and time? Only one, second one. So this is how you choose one of the equations. And why are we using only these three equations? Because the ball is falling freely. Ball is falling freely. Whenever ball falls freely, it is called a case of motion under gravity. This is a case of motion under gravity. And for such cases, this morning we had discussed that for such cases, we take V is equal to final velocity, right? U is equal to initial velocity. S is displacement, A is acceleration, correct? So V, U, A, S. These are some terms like final, initial, velocity. A is acceleration, and S is displacement. Remember, this is displacement. How far has the ball displaced, right? Now see how far has the ball displaced. Have a look here, everyone, on the buildings, like on the wall itself. See, on the building wall, I'm drawing this blue color arrow. This blue color arrow is telling me how far has the ball displaced. I will repeat, the blue color arrow is telling me how far the ball has displaced, right? So I have to find out that first and then find out h, correct? So let us say, such questions you have to come up with this understanding that this is a case based question. You will apply two cases. Case number one, with the given condition. What is the condition given? That total time taken is t for the ball to cover a distance of h naught, but this is displacement of the ball. S is displacement and not distance, and displacement always has a direction. Since the ball is going downwards, so the direction is negative. Of course, its magnitude is h naught, right? Because the ball is coming down. So let's substitute this condition. You will get, let's write the equation. S is equal to ut plus half at square. We were told that the ball is released. Whenever the ball is released, in that case, u is 0. So take u as 0, right? You will get, instead of s, substitute minus h naught. For motion under gravity, always a is equal to minus g. So you will write minus h naught is equal to 0 plus half minus g. Time taken for it to reach the ground was capital T, right? So you get a relation between h naught and capital T. The relation is h naught is equal to gt square by 2, right? Now you are being told that find what is the height at t is equal to t by 2. So let's first find what will be the displacement. That is this blue arrow which I drawn. Now I'll replace it with a green arrow. So here, have a look, this one. We have to first find this value, only then we can find this small h. First find this displacement, then we can find this h, right? So let us find what is the displacement in, let us find what is the displacement s. This is case 2. So two cases, from one case we developed a relation, right? And from the second case we are used to, in the second case we'll use this relation. See how. We have to find s, and we know the formula, s is equal to ut plus half at square. Again u is 0, this term cancelled. This implies s. Now let us take this distance to be any value, let's say x naught. Okay, so we have minus x naught. Why? Because it is downwards, displacement is downwards. So minus x naught is equal to half of minus g, right? And time taken is t by 2. So we'll take t by 2. So second case was for t by 2 unit of time, correct? So this gives you the expression. See, minus and minus on both sides will get cancelled to give you x naught is equal to gt square by 4, correct? Gt square by 4, right? Now relate the two expressions, as simple as that. See, we got h naught is equal to gt square by 2. This is the first relation we got using case 1. Then using case 2, we got the displacement of the ball, this displacement x naught in time. Initially time was 0. In time t is equal to t by 2, we got the displacement x naught. We have the total height given in the question as h naught. This is h naught, right? We are being asked how far above the ground the ball is. That is, this small height h is being asked in the question. So we found x is equal to gt square by 4. Write it here, gt square by 4, right? So depends what is the option given in the question. So if you want to find x naught in terms of h, just divide these expressions. You will get h naught by x naught is equal to 1 by 2 upon 1 by 4. That is 4 by 2 or 2, which implies x naught is equal to h naught by 2, which is also evident, right? We can see directly here that this is nothing but h naught by 2, correct? So you have x naught is equal to h naught by 2. Once you have this expression, you can very easily find out. You can see in the figure that small h plus x naught is giving you capital H naught. Value of small x naught came out to be h naught by 2. So you will have small h is equal to h naught minus h naught by 2, which gives you h naught by 2. This is your answer. So question was how far above the ground the ball is placed at t is equal to t by 2. So your answer comes out to be h naught by 2. I hope it's clear to everyone. In case you have any queries, just let me know. I will bring the sheets one by one in front of you again. Yes. Right? Okay. So class, any queries with this or maybe this part? Anyone, you may let me know. I think Fire, yes, maybe my answer is not matching with yours. Yes, please tell me, Fire. Yes. Maybe we might have
Sir,
some error somewhere. Yeah, tell me.
yeah, it's t by 2 whole square, so it would be gt square by 8, right?
Let me check. It is t by 2. Okay, okay. We haven't taken square here. Okay. All right. Thank you very much, Fire. Thank you. All right. So class, please make this correction. We have uh, with us this expression here. We had to substitute instead of t by 2. So we'll get 1 by 2. I'll repeat it. So yeah, you have x naught is equal to t times of g times of t square by 4. So this will change the answer a little bit. You will get x naught is equal to gt square by, okay, 8, right? 4 into 2. So gt square by 8. So you will have this here as 8, right? Which is h naught by 4, right? And therefore this is 4, right? This one is also 4, and so you will have h naught by 4 here, so you'll get value as 3 by 4 h naught. Thank you, Fire, for bringing this into attention. Thank you. So it got slipped here. See, what was the correction? Instead of t, you have to take t by 2. So mistakenly we had taken this value. No worries, right? That's a calculation error, but I hope the concept is clear to all. Thank you very much, Fayad, for bringing it to attention, right? So class, let us now take another question. Anyone? Okay, wait, anybody, any other doubts, class? Please let me know. Anyone? All right, so if it's clear, just the last question. It's a very interesting question. Again, this is one of the most probable questions which may appear in this year's paper. Of course, not exactly in this way, but this concept may be tested. What is the concept? The question says that you have a balloon, okay? The balloon takes off from the ground. Initially, its velocity is 0. After some time, and it rises with a constant acceleration. The balloon rises with a constant acceleration a. Why am I saying it constant? Because 2 is a constant, right? 2 is a constant value. So it is having a net acceleration upward in the upward direction as 2 meter per second square. Now it says that it rises for 1 second, right? So it rises for 1 second with this value. So if at t is equal to 0, it was on the ground. At t is equal to 1 second, it's over here in the sky. Now you are being told, find out the velocity of stone at t is equal to 1 second. So when the stone is actually dropped, see what is written? The stone is dropped, right, from the balloon. So dear students, here is what I wanted to introduce you all, or in fact you all were introduced already. I wanted to bring this point into discussion about frame of reference. Frame of reference. So when we talk about frame of reference, I mean with respect to whom are we talking about? So when see the question again, the question says the ball is or the stone is dropped from the balloon. So although the stone is dropped, right? So when the stone is dropped with respect to the person on the balloon, the velocity of the balloon is 0. The velocity of the stone is 0. I will repeat, with respect to person on the balloon. So we are talking about when the stone, so I'll write this, when the stone is dropped by the man on the balloon. Please take this as a note. This is a really important concept. When the stone is dropped by the man on balloon, right? By the man on the balloon, we have the velocity of the stone with respect to this man. So let us name these people. Let us say this man is A, whereas man on the ground who is seeing this entire balloon man setup is B. So velocity of stone with respect to A, that is the man on the balloon, or let us exchange their names, right? Because B is for balloon, so maybe it will be easier to comprehend. So let us say this man is B, whereas this man is A on the ground. Okay. Now we will have velocity of stone with respect to man on the balloon is equal to 0. Why? Because in the question it is written dropped. We just discussed in the last question, whenever we talk about dropped, see here, we were told here dropped. Whenever we are dropping a stone or anything, any body from a height, it means it has been released. You don't apply any other energy to it, right? Or no other velocity has been given to it. So you have velocity of stone is 0 with respect to this man. But what about the velocity of the stone with respect to A? Is this also 0? No. Why? So I'll give you an example. For the man who is standing on the ground, what is he seeing? What is he seeing? He is seeing that this man in the balloon along with the balloon is rising up. I will repeat. The man on the balloon along with the balloon is rising up for this man over here, right? So this man sees balloon and all its contents also rising up. I will write this down because this is really important. For A on ground, for A on ground, balloon and all its contents have a velocity upwards, right? Have a velocity upwards. So what does this mean? It means that let us find out what is the velocity. So we know that V is equal to U plus AT, right? For the balloon, initial velocity was 0 given in the question. We are being told that the acceleration is 2 upwards, therefore plus 2. Time is 1 second. It says that velocity is 2 meter per second after time t is equal to 1. So in the given picture in the question, here velocity of the balloon upwards is 1 meter per second, right? 1 meter per second. So we'll have the balloon as well as its contents, that is the stone, everything have a velocity 1 meter per second in the upward direction. For whom? For the man on the ground. Although the balloon, the stone is at rest with respect to the man holding it, but the stone is still moving for the man who is on the ground. I will give you an example. So suppose you are on a train, okay, right? Now you have suppose a packet of snack along with you, right? You are showing it to your friend who is standing here on the road, right? Or maybe it's a vehicle. You have a packet of some snack with you, right? So this vehicle is moving ahead. For this man who is holding this packet, let's say this man is B, while you are here A. So this man who has the snack packet, for him the snack packet is not moving. So the velocity of snack packet with respect to B is 0. Whereas velocity of snack packet with respect to A is not 0. You will still find the snack packet moving away from you, right? Am I clear, class? What I'm trying to tell, that with respect to this man B, the stone is not moving because he is holding the stone. Whereas with respect to the man on the ground, the stone is moving because entire contents of the balloon along with the balloon are moving, seem to be moving above. So what happens when he leaves the stone? So please draw this, draw these contents along with you. So see what happens when he leaves the stone. See here, the man who is on the balloon will see the stone falling this way, straight downwards. This is the motion of the balloon for B, a motion of the stone for B. Whereas for the man who is on the ground, he will see as if the balloon has been, see the balloon has a velocity 1 meter per second with respect to this man A. So he will feel as if the balloon was going upwards Suddenly, the man on the balloon left it. So he will feel as if the balloon, as the stone goes up and then comes down. See, so much a difference in perspective. The man on the balloon will feel the stone is coming down just in this direction, whereas the man who is on the ground will feel that the stone was going in the direction upwards with velocity 1 meter per second. It flew high to to some height and then it is coming down. So this is the difference I wanted to bring into consideration for all of you. Now that this is clear, see, so the first part of the question, have a look at the question. Question says velocity of the stone at 1 seconds or time t is equal to 1 second. So velocity of the stone with respect to the man on the balloon is 0, whereas velocity of the stone with respect to man on the ground A is non-zero, 1 meter per second in the upward direction. You can write it +1, right? This is first answer. Second, what is the height of the balloon when the stone is dropped? That is at t is equal to 0. You have to find height. Very simple, height and time, one relation. S is equal to ut plus half at square. Please mind that question tells you that u is equal to 0. So this is 0. The body is going upwards. So we'll take S as positive, right? G is A is minus of G. Sorry, here in this question, A will not be minus of G. Why? See, look at the question. It says that the net acceleration is upwards, right? So you will have no G component, and rather, although there is vertical motion, although the motion is in the vertical direction, still A is not equal to minus G. Why? Because the balloon has already overcome the acceleration of the earth, and here there is a maybe a fire, maybe here a fire heater is involved, which is powering this balloon to go up, or maybe some kind of engine, some fuel, whatever, right? So here A is not equal to minus G. Please mind this, because the question says net acceleration, A net is equal to 2. So we'll put 2 here with the positive sign because acceleration is in the upward direction, right? And time t is equal to 1. So you will get S is equal to, here S is equal to 1 meter. Correct? So the height of the balloon along with the stone when the stone was dropped is equal to 1 meter. I hope this is clear. Then next one is total distance covered by the stone. How will you find it? See here, the man is over, like I'll try to write it somewhere. So just give me a second. Yeah, so I'll write it here. See, the stone was thrown upwards from the balloon. It is already at a height of 1 meter, right? It is already at a height of 1 meter. What is the velocity of the stone? The velocity of the stone was also 1 meter per second. So we'll write here u is equal to 1 meter per second. And this is actually the balloon. From here the stone was thrown. So what happens? The case becomes the balloon or the stone is at 1 meter from the ground, right? It has been thrown with velocity 1 meter per second. We have to find out how much total distance has the stone covered. Now class, now I am splitting this motion of the stone. Please listen carefully. I am splitting this motion of the stone into 2 halves. One, it will go above to a certain height and then come back to the same height. Class, remember today morning we have read that what is this maximum height reach in terms of velocity u naught. H max is equal to u naught square by 2g. Therefore, u naught in this case is 1. So you will have 1 square by 2g or 1 by 20. 1 by 20 is the maximum height reached. So this 1 by 20 meters. All right. 1 by 20 meters. Now, what is the height of the balloon initially when it was thrown, or the stone when it was thrown? Height of the stone when it was thrown was 1 meters from the ground. So the stone basically goes up to a height of 1 by 20 meters and then again comes down. So it travels 1 by 20 here and then 1 by 20 again here and 1 here, right? So you have 1 by 20, 1 by 20 and 1. This is the total distance traveled. So distance is equal to 1 by 20 going up, 1 by 20 coming down, and then again traveling to a to the ground by 1 meters. So this will give you the total distance covered by the stone. I hope the concepts are clear with all of you. In case you have any doubt, I'll be uploading this lecture on the YouTube channel Physics with Fatnani, and you all are most welcome to visit that and check it out. If you have any queries now, you may let me know. This was the last question. We'll try to continue ahead of this in the coming class, right? Where we'll quickly see what are 2D, what is 2D motion, right? Vectors, and I'll try to send you all some formulas. Try going through them so that our class in the morning will become much simpler, right? So I'll send the notes, look at them, and ask me any queries if you have. With this question, coming back, any queries, class? Let me know. Anyone? Anyone? Any queries? Please let me know.
So can you explain again how is the initial velocity of the stone 1 meter per second?
See, I said that velocity of the, okay, I'm sorry, this was 2 meter, no? I think I've mistakenly written it as 1. Sorry for it. Very sorry. Yeah. Is it clear now? Was this the
Yes, sir.
doubt?
Yes, sir.
Was this the doubt?
Yes, sir.
Okay. Thank you. Thank you very much. So in that scenario, you have 1 by 5 plus 1 by 5 plus 1, right? That is 1.2 plus 0.2 plus 1, that is 1.4 is the total distance traveled. Plus, I would like to clarify. So, right here we obtained, until here everything was correct. Here we had taken it as 1 instead of 2. So what is happening? I'll repeat in a brief. A balloon takes off from the ground. It goes to a height. It is accelerated with an acceleration of 2 meter per second square. It attains a velocity of 2 meter per second. The balloon attains a velocity of 2 meter per second at t is equal to 1. This is we calculated. Here, when it started off, its velocity at t is equal to 0 was 0. It attains a velocity of 2 meter per second. At this point of time, a stone was dropped, but the stone's path covered for the man on the ground is something like this. So the man on the ground observes that the stone goes above with a velocity 2 meter per second, not 1, right? Pardon me for the same. It goes with a velocity 2 meter per second upwards, then comes down and falls on the ground. Now that it falls on the ground, we have the distance traveled. So I told that we'll split it into 2 parts. One is this motion, right? And the other is the motion downwards. So we remember that when any object is thrown from the ground or from any height and it returns back to the same height, so we can calculate what is the maximum height which was reached by the stone. So this maximum height reached by the stone, h will be equal to u naught square by 2g, that is 2 square by 2g, right? That is 4 upon 20 or 1 by 5. So this height came out to be 1 by 5 meters. So the stone travels up by 1 by 5 meters and then comes back down by 1 by 5 meters. And then again, it returns to the ground, traveling, already it was at a height of 1 meter. So it again travels that height and reaches the ground. So the total distance covered by the stone, is 1 by 5 plus 1 by 5 plus 1, that is 1.4 meters. Thank you for bringing this into attention. Thank you very much. Yeah. And thank you everybody for understanding, right? Because so many figures and the space construction is there. So sometime or the other, I might be tempted to maybe do some calculation error here or there. So thank you for that understanding. And yes, class, anything else anybody wants to convey or ask? That is why. So basically this is a one-on-one class. In case you all remember that on the first day of the class, I told that this class will be a partnership between me, you and God himself, right? So for that same purpose, I always ask you all to keep verifying. Thank you everyone for this. Actually shows that you all are actually taking part in the class and doing things accordingly. Thank you very much for this. So here this was 2 meter per second, and this was also 2, right? Right. So I think now the concept is clear at the end of everyone. Go through it. I may or may not be uploading this session. I'll try to upload, right? And in case there are any queries, just you all are most welcome to shoot them. Yeah. Class, anyone, any queries? Please raise your hand. Let me know. Yes, class. All right. So I assume the queries are cleared at everybody's end. Try resolving this assignment 1 week later. 1 week later, perhaps you will still get some doubts. In case you do ask me, right? All right, class. Then thank you very much, all of you. Thank you for being in the session. Let us join tomorrow morning early at 8:50. You all might be sorry. So you all might have to wait for 10 minutes. So please do that. And then from 9 o'clock, we start, right? So yeah. All right. Thank you very much. Thank you. Thank you very much. Anything, any queries, always feel free to share and we can work on that. Thank you, class. Thank you very much.
Thank you, sir.
Thank you, sir.
Thanks a lot. Thanks a lot, everyone. Thank you for your attention and kind cooperation. Thank you.